Hey again, everybody. In this video, we're going to start working on our shared infrastructure library. So we have our shared domain library, which, as we talked about, is a set of base classes that can be reused across the different domain layers of the microservices we're going to build. We're going to build an equivalent library for the infrastructure layer that can be used across the different microservices. So we're going to add a new class library here, and this will be shared infrastructure. We want to store it in our shared folder here with the domain. And one of the first classes we can implement here as a base class is going to be the actual implementation of a base class for our repositories. So I'm going to go ahead and create a folder. And we're going to create a repository class in there. So our repository class is going to be a public abstract, and it's going to implement our interface iRepository. And we're going to have, it is a generic, so we want to pass in a T here. We don't have a reference yet, so we're going to go ahead and add a reference to our shared domain from our shared infrastructure to get that interface. And the other thing we need to do is, just like on the interface, where if we pop over to the interface real quick here, we've put a where clause on it that T must be an aggregate root. We want the same thing here in order to be able to implement that. So T must be an aggregate root because, as we've talked about, what moves in and out of the repository layer are aggregate roots and aggregate roots alone. So I'm going to use our little shortcut method here to add our methods that we need to implement. Just going to rearrange them a little bit. And so we basically have the foundation of what we need to be implementing here for our repository class that is reusable. So the repository class needs a couple things passed into it. First off, we need an iUnit of work. And as we've talked about before, unit of work is basically the boundaries of a transaction. So when a request comes into the server from a caller, we're going to start a new transaction. And once we're done building out the response to the caller and sending that back, we're going to finish our transaction. So there's going to be a database transaction, and all of that's going to be managed by our iUnit of work. The other thing that I'm going to pass in here is a user session. Now we haven't actually built that yet, so we're going to have to come back and we haven't created that interface yet, so we're going to have to come back and we're going to add that. But what I wanted to do here, and we're going to make this nullable. So there's a lot of times where we're at the database level and we want to be able to fill in our let us actually come on over to our aggregate root here class. We want to be able to, when we're saving our aggregate root to the database or updating it, we want to be able to use the set creation audit fields, set updated audit fields to represent who was the last person to touch the object. And in order to do that, we need information about the user. So what I like to do is actually pass in an object that we're going to flesh out called a user session. User session is going to represent, we were just talking about when a caller makes a call, we're going to start a new transaction. That's also the lifespan of the user session. So for each request that comes in, we're going to, when the request starts, build an object called the user session, which is going to give us information about what user is making this call, and we're going to have that available as an injectable into wherever we need it. So if we at any point during the request need to get information about the requesting user, we can use the user session to do that. And so what we need, because we're going to need that in our methods here, we're going to need that user session here. So we need to add that. So we're going to come into our shared domain again, and what I'm going to do is create a new folder here called user. Oh, sorry, I'm getting lost. So we're going to create users here, and this is going to be a service, and we're going to have an iUser session. Public interface. Alrighty. So we're going to have an iUser session, and what we want to be able to do is have that have a property that has a user on it. So we've got to go build that in a second. But we're going to have a property on it that's going to be accessible, that's going to tell us the user. And then we're going to need a couple different methods that are going to be used a bit later on, and we'll see how, that are going to allow us at the beginning of the request. As I said, what we want to do at the beginning of the request is determine who's making the call and load a user session based on that information. So we're going to have a method here that's going to allow us to set various properties about the user session when it's loading. Now, there are some calls that we might want that are actually going to be an anonymous call. There are some endpoints or some requests that may not require us to actually have an end user, authenticated end user making the call. And so we still want to load a user session for those, but we're going to have a method load anonymous user session, which is going to allow us to know and distinguish by looking at the user session, are we dealing with an anonymous call or an authenticated call to the backend. Alright, so we still need to add our user. So the other thing we're going to do here is in the root of the users folder, create our user. And this is going to be a public class, and it's going to be an aggregate root. And we are going to have properties that pretty much mimic what we just saw when we were building out the load function on the user session. Again, private sets. And so we're going to have a external ID, which is going to be the ID that represents the user in whatever our external authentication mechanism is. So my preference is always to use some sort of third-party authentication tool like Auth0, Firebase, or things like that. And whenever we create a user in one of those services, it's going to get an ID, and that's what our external ID is going to be. Whatever the ID is that was assigned by the external authentication system. So I'm going to shorthand this a bit, copy and paste some strings. We're going to have a first name, we're going to have a last name, we're going to have an email. First name and last name are going to be nullable. And then we can have our constructors. Pass in our properties. Thank you, IntelliSense, for helping me fill that in. And we can leave it at that for now. We're probably going to come back and we're going to add a little bit to this as we start to flesh out the loading of the user session and so forth. But we've got our user class at its basic level. So again, we have this object that's going to represent a user that's going to represent the caller, the authenticated caller of our API endpoints. So now we can see that we no longer have our squiggly here. So we have our iUser session interface, which is going to give us access to whoever the user is that's making our the actual call. So we come back here, we add in that, and we've got the two dependency injected things that we need to implement our base repository class now. So next up, we need to actually store. What we're going to do is we're going to take our we're going to go protected on these. What we want is a reference to our unit of work internally. And same thing for our user session. And then for brevity, in our other repositories that we're going to write, we want access to what is going to be the document session, which is something that's going to come from MartinDB, which is the library we're going to use for interacting with the Postgres database. All right, so let's look at our unit of work again real quick. So in our unit of work, we have this thing called a session, which is going to give us access to whatever underlying persistence layer tool we're using, whether it's Entity, Framework, and Hibernate, or in this case MartinDB. You can give us access to all of those things. Usually have something called a session, which represents basically the transaction. So we need access to that. And so over here, we're actually going to cast it as a document session, which is something that comes from MartinDB. So what we need to do here is we need to add a reference now through NuGet. To MartinDB. Let that do its install. Come back now. And that's our session. So what we're going to be able to get from the unit of work, and we'll see how that happens, but there's the property off of the unit of work, which is going to be a session, and in our case is going to be a document session, which is something that comes from MartinDB that represents the transaction that MartinDB has opened for our calls to the database. All right, now we can actually start implementing our methods. So this is where I think, it's MartinDB really shines, makes this quite easy. So one of the things we want is the ability to get a particular object by its ID. And what I want to do is, if the object that we're looking for does not exist, throw in an exception. All right. Now, one of the things that we have an issue with here is that it does not recognize object not found exception. So what I like to do is actually have a couple classes in the libraries that represent common exceptions that might be happening at the business layer or at the infrastructure layer, and ways to manage that. So in our shared domain here, we're going to add a new folder called exception. Oops, sorry, we want a folder first. I'm going to call it exceptions. And we're going to add a new class for object not found. All right. So we're going to have, basically this just is inheriting from the base exception class in C#. And we want the ability to pass in the GUID. And we got our first base class. So there's also cases where we want to pass in the type of the object. So we want another additional override here. Here we'll do so now we're able to even be a little bit more specific, not just having an ID, but the type of object and the ID that we are not able to locate. So now, there we go. And then what we can do is so now we can throw an exception that says we were not able to find an object with the ID that we were given. All right. So then what we can do is we can do our insert. So here's where we want to take the incoming aggregate root, and what we want to call on it is our set creation audit fields. And this is where we're going to end up using our user session. In fact, I'm going to make an adjustment on the fly here. We're not going to make that nullable. We're going to require it always. And we're going to make sure that there's always a user assigned, even in the anonymous world. What we might want to do there is have some sort of system account that represents the call. And that's what we want to do there. So the other thing you'll notice is that we're using datetime offset UTC now. Again, a preference thing highly recommended though is store into the database. Whenever you're storing dates in the database, store them in the UTC time zone. You don't know where your server is going to run, especially in the cloud world these days. Like, you might have a server that's running in the East Coast data center, the West Coast data center, both. And if they're all writing to a database, you don't want to be writing to the database with times that represent the time zone in which the server is in, because, especially what if you move your server? Now you got to think about, okay, well, when I originally saved this data, it was all in the Eastern Standard Time zone. Now it's in Pacific time zone. You don't want to have to worry about any of that. So make all of your dates time zone agnostic when you save them by using UTC. So we are storing and we are creating here the UTC now as the date timestamp. Now that means you got to convert it on the way back out, but you can convert it now to whatever time zone you need. Might be the end user's time zone, might be a time zone that you're in if you're writing a report, but everything is going to be relative to UTC now. So very much encourage using that practice. All right, now we're going to reference our unit of work here. And one of the methods that we added to our unit of work, let me bring that guy up real quick here, is add domain events. So whenever we are in the repository, we've received an aggregate root. The aggregate root may have issued some domain events while various methods on the aggregate root were called, and we're going to see examples of that. If we come over to aggregate root real quick, and I'm sorry, we got to drill down into entity. Entity internally has a list of domain events where we're going to leverage these methods of adding and removing domain events, primarily add, to add domain events that we want issued when this object is being stored. So an aggregate root will keep track of what domain events need to be issued, and at some point we need to issue them and take care of those. When do we do it? Well, we're not going to actually issue the domain events right here, but when the unit of work is finishing up its transaction and we're ready to commit the transaction, right before we commit it, we're going to issue all of the domain events. So to make that easier for it to keep track of, well, what are the domain events it needs to issue within the unit of work? Whenever we're inserting, updating, deleting, we are going to pass in the domain events that are tied to a specific aggregate root. So our unit of work is going to take in an aggregate root, and all it's going to do is loop over all of the domain events that are tied to that aggregate root, adding it to its overall list of, hey, here are all the domain events that I need to issue. Because within a single transaction, within a single unit of work, we might be touching more than one aggregate root. So we might have to have domain events that are spanning multiple aggregate roots, and we need to keep track of them all. All right, so here we are going to leverage Martin to store our aggregate root, and then we are going to simply say task completed. And that's it for our insert. The beauty of using MartinDB and also in using a Postgres as a NoSQL solutions means that we're actually just going to serialize our aggregate root, and that's what's going to go into the database. So we're going to end up in the database with our aggregate roots as documents. We don't have a lot of relational data that we need to keep track of, and don't have to manage columns and joins and things like that, which makes it much easier in my opinion. All right, so now we can actually create our update, and I'm going to cheat here because right there, that's the only change we need to make. Is in the update scenario, we want to set our updated audit fields, but again, we want to add whatever domain events we need to add to the unit of work. We want to store our document through Martin and then complete our task, and we're done. And then for delete, we still want to, don't have to update any fields. We still want to pass in any domain events that might be related to that. Here we're going to delete by ID, and we're done. So That's it, really. So we have the base for our repositories that we can use when we're building out our other service, our microservice layers, the infrastructure layer of our microservices. All right, so we've got that taken care of. And one of the other things we have to implement here in its concrete form is our actual unit of work. So we can come in here and we can now add unit of work. This is actually going to be a public class. We're not going to be inheriting from this thing, so it's not an abstract class. We do want it to be a sealed class. We don't want people inheriting from it. And here we are going to be implementing our iUnit of work. And we're also going to implement iDisposable, and we'll see why. All right. Let's go ahead. I don't know if I want to add those just yet. So what I'm going to do is, first of all, come in here and say, all right, we need to be tracking a list of domain events. So we just saw when we were writing our repository-based class that we need a place to be keeping track of all the domain events for the entire transaction that we need to eventually issue. So we're going to do that here. We have an internal list. One of the other things too, I think I might have mentioned this when we were talking about the interface. Sorry, that we want to be able, we want to create an ID, a unique ID that goes with the unit of work. It's not really serves much purpose other than for debugging purposes. It allows us to keep track of and compare our two unit of works equal, because sometimes with the dependency injection, you want to make sure that it hasn't given you a new instance of a unit of work. You were expecting one that was already created. And this just makes it easier to compare those and determine if that's truly the case. All right, and then we need our, we're also going to have a document session in here. Again, this is going to come from Martin. Store. All right, so what we're looking at here is we're going to get a document store, and we're going to add that up here as an incoming parameter. And that's a Martin concept, which basically represents the overall document store. And from that document store, what we can do is create a new session. So that's what we're doing with document store.lightweight session, is we're getting our actual session object, which we already saw in the repository is going to be used. The session object is what we're going to use to actually write queries that to retrieve things from the database, but we also saw how we are using it to actually make the calls to say, go store this document in the database for us. All right, now we can expose a couple properties here. We can start with our ID property. So we're going to have a public GUID that's just going to return our ID. Sorry, did we not implement that? Let me just check something real quick. Got our ID there. Yeah, I'll figure that out in a second. Not sure what's going on there. Ew. It brought in the unit of work from Martin. My apologies. I'm not using that one. All right, so we got our unit of work ID, and then we're also going to have our session. And now we need to start implementing some of our methods that we're going to have that are coming from our iUnit of work. So the first one we're going to implement is our commit. So this will be when we're ready to actually commit our unit of work. So if we've done multiple things against the database, we're ready to close out and commit our transaction. This is what we're going to end up calling to make that happen. So we've been talking about domain events, and that at some point we need to actually issue these things, let them do their magic, and complete. So if you remember when we were talking about domain-driven design, there's a distinguishment between two types of events: domain events and integration events. Domain events stay within the bounded context or within the microservice, and they are meant to be completed, and therefore should be fast before they are meant to be part of the same transaction that you're running against the database, so the same unit of work here, prior to actually committing the true transaction and sending the response back to the client. So what we're going to do is we've been keeping track of our domain events, and so while the count is greater than 0, what we're going to do is we're going to await. We're going to create a new class here called a domain event dispatcher. So we're going to create a class in a second here called our domain event dispatcher, which is actually going to take care of dispatching the domain event. But what we're doing here is we're taking the one at the 0th place within our domain events list, dispatching it, then removing it. So why in the world aren't we using just like a for loop? Well, because during the actual dispatch, we may end up with more domain events that get issued. So a domain event, and when you're handling a domain event, could trigger other domain events. Therefore, we don't know exactly how many domain events they're going to be just from looking at the list when the commit is called. So there could be, say, 2 domain events when commit gets called, but one of those domain events might issue another domain event. So in reality, there's going to be 3. So that's why we have the domain event count greater than 0. So as long as we've got domain events left in the list to issue, and we may add domain events to that list after we fired a domain event, that's why we're basically waiting until we get down to 0. We're going to dispatch whatever's in the 0th position, remove it from the list, and keep going. Once we have done all of that, then we can actually finish our database transaction, and we're going to rely on the save changes async method of Martin, which is actually telling it to save the session, save the changes, which completes our transaction. All right, now we have a bunch of other methods we need to implement here. So we also need to roll back. So if we're rolling back, the good news is there's nothing that we actually need to do. When we actually dispose of our session, it's going to roll back. So we don't actually need to roll anything back here at the moment. We can just basically return it as a complete. So why even have it at all? Just because if you ever want to swap out the document session MartinDB approach for something else that does actually have a rollback call, you can actually end up having this method here and available. So we want our AI unit of work to be usable ideally across if we ever do change and swap out from MartinDB to something else. So it's really for that reason alone. Then we need our add domain events. We saw this. I'm going to flip back to it here in a second. Here, aggregate root. We saw this coming into play in our repository class, right? So over here, add domain events. Again, what we talked about is whenever we're doing our inserts, updates, deletes, we want to be able to pass the aggregate root that we're saving to the unit of works add domain events and let it internally say, all right, let me grab a copy now of all of the domain events associated with that aggregate root. So here we're just going to have a for each domain event within the aggregate root. So fix some IntelliSense here. All right, so for each of those, if we don't already have the domain event, want to add it. So again, this method is just simply looping over the domain events of the aggregate root and adding it to our internal aggregated list of all domain events that we need to issue. So the other thing that we talked about, we can look at it here. So we also have methods related to caching. So the ability to cache an entity, remove an entity from cache, and a couple gets. And so we're going to implement those now. So we're going to do void cache entity. And again, as a reminder, this is not caching across requests. This is simply within the same unit of work, within the same transaction, within the same request coming from a caller. We might end up asking the repositories to retrieve the same object more than once. And for those cases, we don't want to have to go to the database every time. So we can just pass back a reference to the one that we've already pulled from the database if it's being asked for a second or a third time. But again, that's not caching in the sense of a cross request. So this is just in memory for the life of the request, and then this cache is gone because the unit of work is destroyed once the request is done. So it's not a full purpose cache. It's really just for that situation of caching within a particular request. So we need a key that we're going to use to reference the item in our cache. Oh boy, can't spell. And we want it to basically be a combination of the ID and the type. So the ID and the type of the object is what's going to end up being our key. And then we need someplace to cache them. So up here, we're going to come in, we're going to say read only. We're just going to have a simple dictionary. All right, and you'll notice, sorry, that there's one other object that we're going to need to implement here, which is the cached entity. I like to simply put this as a child class right within the unit of work. And actually, let's call it cached aggregate root to be more specific. And so what are we going to have there? We're going to have an aggregate root that we're caching. So we might come back and add some properties of this later, because for now it kind of looks like we're just creating a class to wrap a class. Essentially that is what we're doing, but there's a couple of things that we might want to do from serialization and some other things perspective. So rather wrap it in a class for the moment. All right, so now that we have our key, we need to actually add it to our cache. So we're going to say cached entities, oops. Where we're going to give it the key and then the aggregate root. Oop, my bad. Our cached entity, which is a wrapper around the aggregate root. Okay, so that's caching our entity. Then we need to be able to, the other method we got here is we need to be able to remove it. And you know what, I'm sorry, I'm going to update these to be more accurate. I don't want to intermix the terminology here of an entity and an entity in the sense of domain-driven design versus aggregate roots. So here we're also going to need to, I'm just going to copy it here, we're going to need to generate the key. And I should be paying closer attention to the code I'm writing there. Sorry, that should have been aggregate root. We have our key, and then all we want to do is remove from our cached entities that item. And then we have a couple gets. So we can say sorry, I'm just updating the lingo here a bit. So we're going to say get cached aggregate root. And what does this method do? Well, again, we're going to need to generate the key, and it's going to be the same pattern. So we're going to start with our ID. And then we need to get the name of the object from our type of, oh boy, type of T, dot name. So again, it's going to be the object ID plus the type. And then we're going to say if cached entities try get value. All right, what did I screw up here? Cache aggregate root, what does it not like? Cache entity. Well, there's a couple of things that need to be cleaned up here for sure. So let's take care of that. I'm sure I'll figure it out as we're going to. Oh, yes, yeah, we never updated this. That's why. All right, so now that we've updated that, we should be good. All right, so now we've got our cached aggregate root. We have a get method where we can get a cached aggregate root by an ID. So this allows us within our repositories to say, all right, check to see if we've already got the thing in the cache, and if we do, grab it and just return it, as opposed to going to the database and getting it again a second time. All right, we've got another method that we use for getting cached aggregate roots, where we can basically pass in a function that we want to filter by. All right, and so here we're going to do IEnumerable. Matching aggregate roots, where we're going to look at our cached entities, and I'm going to change that to aggregate roots as well. We'll do a little bit of name cleanup here in a second, and then we've got to update our interface as well. Sorry, I'm typing this out, and then we're going to chat about where we need to convert it or cast it. Okay. Now, what are we doing here? We're basically looking for anything in the cached aggregate roots world where the aggregate root that we have cached is of type T, and where we apply whatever filter function. Our filter function is going to take a T into it and return a Boolean true or false, and that Boolean is so within the filter function is going to have, it's just, it could do whatever it wants, it just has to return true or false, and if it returns true, then we're going to include it in the matching aggregate roots. If it returns false, we're not going to include it in our matching aggregate roots. So that's our where clause. And then what we want to select and return are a list of aggregate roots. So we just need to take our aggregate root value and cast it as T. And then we need to eventually return something back from the method. So what we're going to say is if matching aggregate roots, if the count equals exactly 1, we can just simply return that aggregate root. Right? So if we found one match, we can return it. If we don't have any matching, we can return the default. Sorry, return default, my bad. And then finally, we can throw an exception if we found more than one matching we can let the caller know that we failed to get a singular cached entity based on the filter that was provided. So this is going to allow us to get those retrieve those entities. Now, one of the things I said we've got to do is clean up some nomenclature here. So let's rename this to cached aggregate roots. Let's come over to here and we're going to say remove cached aggregate root. So when I was originally creating these function names, I meant entity not in the domain-driven sense, but more so just as a a general sense. And so I don't want that language to confuse us at all, because I don't want it to be thought of as the domain-driven design version of entity. So really should be calling it aggregate root. And you can see now that we've cleaned up our naming, we've successfully implemented our iUnit of work. So we do have to implement our dispose method. What do we not like here? I'll come back to that in one sec. We do want to implement our dispose for iDisposable. Which means we want to make sure we're calling the dispose method on our session that we got from Martin, that we want to make sure is we were closing out the transaction and we're completing it and we're rolling back if necessary and things like that. We just want to make sure that we don't leave open sessions against the database, which would leave open connections and transactions, which would obviously not be a good thing. So that's why we have our dispose method and we're implementing iDisposable. All right. We still have to implement our domain event dispatcher class. Why don't we go do that real quick? So we're going to come back in here and we're going to first add an interface in our domain layer. And there's only going to be one method on it, which is actually going to be the method that goes ahead and dispatches a domain event, as we saw, being used in the unit of work. So that's our interface. Now we're going to implement our concrete class. All right, so here all we got to do is actually go ahead and issue our domain event, and we haven't talked about it yet. We haven't had a need to. There's a library in C# that I'm a huge fan of called Mediator, which helps us implement the mediator pattern, which allows us to have classes that basically Mediator acts as like almost an internal in-memory event bus, if you will, connecting the publisher of a domain event or any event. It doesn't have to be a domain event. In Mediator, you can publish events and subscribe to them. So you can say, all right, when a particular event is issued, I want this particular class to be the handler that goes ahead and handles and responds to that event. So we're going to use Mediator to actually handle and issue our domain events. Hence, we need to come in and add to our library a reference to Mediator. And what we're going to do is take in a reference to the mediator. And our actual implementation of the dispatch method is going to be pretty straightforward in the sense that we're just going to issue our domain event or publish it using mediator. So our domain event dispatcher is really just a very small wrapper around the concrete implementation of mediator. So it's going to publish our domain event, and we'll see how those domain events are eventually consumed by handlers and how we wire all that up to say that, you know, this event should be handled by this particular handler. But that's our domain dispatcher, domain event dispatcher. And now we just need to add it as a injectable dependency. Let's see here. It's complaining we didn't do dispose. Oh, didn't spell it correctly. So now we're good on all those fronts. Now we just got to figure this guy out real quick. Constraints of T, good, must match the constraints for the parameter of type T, get cache entity, considering. Oh, I wonder if my bad. We need to restrict this to aggregate writs that are being cached. And now we got rid of our writ squigglies. Okay. In our infrastructure base class, we still need to wire up a couple more things, which is related to our iUser session, which again, we're going to be using. So when a new request arrives at the server, we're going to be taking the incoming bear authentication token, which is going to tell us who is making the call. And we want to load up our user session with an object that represents that user that all of the other pieces of the app can use through dependency injection to know who actually made the call. So one of the things that we need to add is an ability to use our database, i.e. we need a repository, to grab a user. Now what we're going to be getting in our JWT token is not the ID of the user that we are going to create for the user, but we're going to get an external ID because we're going to end up using Firebase. Google Firebase is going to authenticate the user for us, and what we're going to get from in the request is a JWT token that was been issued by Google Firebase, and in there is going to be the ID of the user that was assigned by Google. So whenever we have a new user created in Firebase, Firebase is going to attach an ID, a unique ID to that user, and that's what we need to be able to perform a lookup by. So we're going to need a repository that we can talk to our database to grab a user where the external ID, i.e. the ID coming from Google, is something we can look up in the database. So we're going to need in our domain layer, and because this is going to be a repository exclusively used by the user session, I'm going to call it the iUser session repository. And we're going to have a public interface. And this interface is going to end up being able to return users. So we want iRepository of type user. And what we want is the ability to return a user by their external ID, where what we're passing in is the external ID. So that's the interface we want to implement. And so now what we need to do is, in our infrastructure layer, actually implement the concrete version of that. We're going to have a user session repository, it's public, and it's going to inherit from our repository. There we go. And we're going to implement our iUser session repository. So in order to do that, we're going to need to implement the interface. And we're going to need to
have on our concrete version of the class the dependency things that we're going to inject. So now we're going to do something here. So to describe why we're doing this, when a request arrives at the server, we're going to receive the JWT token. It's going to have the external ID of the user, and this might be the very first call that has been placed to our backend for that user. So this user might be a brand new user that just got created in Google Firebase. And if that's the case, if the user just got created in Firebase, we don't know who the user is and we don't have a record of them in our database. So what we want to be able to do is when the request arrives, if we end up getting an external ID for somebody that we don't recognize yet, well, that means that we need to create a new user in our database to represent that person. Now, that's going to require a unit of work, and that unit of work acts as the transaction against the database. But here's the thing about it. We don't want to use, as we've talked about, every request is going to have its own unit of work. Because let's say that the very first request that is being issued is to, I don't know, create a new product in the database, and there's some sort of validation error where, you know, the product name is missing or something like that, which would cause the main unit of work for the request to not be committed and therefore roll back. Now, when we detect, when the request very first arrives, if it's a brand new user, and we detect that it's a new user and we want to create a new user in the database to represent that user, we don't want that to be impacted and rolled back if the main thing that that user is trying to attempt, like in our example, create a product, fails. So if the main thing that the user is trying to accomplish fails and rolls back, that shouldn't roll back and should not impact our ability to actually create a representation of the new user that called. So what we want in this case is a separate unit of work just for loading the user session, so that we can determine, do we have this person in the database, yes or no? And if the answer is no, we can create them in the database, commit that unit of work right away, and then move on to handling the rest of the requests. And so we can't use the main unit of work because the second we commit it, the transaction's closed, and so the rest of the request wouldn't have a unit of work. So we have a separate unit of work, and our dependency injection library that we're using is AutoFac, and AutoFac has something called named versions or instances that you can use. So what we're going to use here is a property or a feature, I should say, of AutoFac that's going to allow us to say that we want not just a unit of work, but we want a specific named instance of a unit of work. And we're going to call our named instance the user session unit of work, and that's all this unit of work is going to be used for. So it's not the same unit of work that's going to be used to handle the rest of the request. It is solely going to be used by our user session loading process. So we need to do that, and I can't remember if we've added AutoFac yet. We have not, but you can see IntelliSense recognizes that this happens to be an AutoFac feature. So handily and very nicely what it did was recognize for us, and so now our key filter, so what this is saying is, yes, for our user session repository, what we need to inject is a unit of work, but not the same unit of work that everyone else is going to get. We want this specifically named instance of a unit of work. So when a request arrives and starts, and we'll see how this gets done eventually, but when a request arrives, we're actually going to create 2 units of work each time. First one is just to be used by the user session, and that's it. The other one is meant for the rest of the request. And the other dependency that we're going to have to pass into our base repository is a user session, but that's what we're building. So that would end up with a circular sort of way of thinking, and so we're just going to pass null in for that user session. And so when we implemented this, we said it was non-nullable, and we're going to have to change that because this is a legitimate case where we do want the user session to be null. It's when we're dealing with the user session repository. So in fact, instead of bastardizing all of our repositories in the base repository for that, because we don't need these other methods here around get by ID, insert, update, and all that, because our user session repository doesn't need all these built-in handy to have method calls. We really just need the get by external ID. What we're going to do is we're actually going to not inherit here, which which means we also have to come over to our interface. We're not going to implement that base interface. And so now what we can do, now we just have to be able to pass into here the same things that we're passing into our base repository class that we built. So if we come over and reference that, what we're going to end up needing is off of our unit of work, we're going to get our session. And so now we have our session object. And it's from here that we're actually going to be able to run our query against the database to get our user by the external ID. So what's nice is, again, Martin makes this relatively straightforward. Whoops, sorry, from result. What we're going to be doing is using the session to run a query against the object of type user, where the external ID equals the external ID that we're receiving in. And then what we want is the first or default of that. So at this point, we're going to end up getting, what's nice about Martin is, again, it's just taking the link syntax and creating an actual query against the database that's going to look in the user table, generate a where clause based on this parameter here, where the external IDs match, right? So this is our repository that's going to allow us to, again, use an independent unit of work to grab a user by their external ID. All right, so now that we have that, we also want to be able to implement in our infrastructure layer here, oops, we want to add a folder for where we're going to put our user session. So users. And here we're going to have services. And I'm sorry, we're actually going to move our user session repository. I ended up putting that in our repositories folder, which is really just for the base classes. So we're going to move that guy here. And now what we're going to do is we're going to implement this here. So it's going to be user session. And he is going to implement our iUser session interface. All right, so now we've got to implement this guy, which is really about loading based on the external ID, loading the appropriate user. And if it's the first time we've seen the user, we want to create a new user in our database for that. So let's go ahead and let IntelliSense help us a little bit there implementing this. We're going to have a public getter, but a private setter. And where we're actually going to take care of loading this user property is in our load options here. So here, if we're loading the user based on the information that we're going to be pulling out of our JWT, we're going to say user is going to get await user repository, whoops, get by external ID async. We're going to get our user based on that. So what do we need to inject here? Well, we're going to need our iUser session repository. Make the name match here, so I should update down here. Some typos. So what we're going to end up with here, actually let's do it this way. So what we're going to do is we're going to throw an exception. No, I'm sorry, we don't want to throw an exception. So what we're going to do is this. So we're going to take our user, we're going to get a user back, or null if we don't recognize, if there's nobody that has that external ID. So when would that happen? Well, if the JWT arrives with an external ID and it's the very first call we've received for that user, then we're not going to have them in our database yet. Therefore, when we do our repository method call here, we're going to end up getting null back. We don't have that user. So we want to detect that, and we basically want to say if user is null, what do we want to do? Well, we want to create a new user based on the external ID that we got, first name, last name, and email. And then we're going to await user session repository. And I lied, we are going to need our insert. I was implying that we didn't need the inserts, apologies. And then we're going to say await the unit of work. Whoop. So again, what unit of work are we talking about here? Well, we need to be injecting the same unit of work that we're injecting into our user session here. So again, we're going to have an I unit of work coming in with one caveat though. The caveat is we're not grabbing the same unit of work that the rest of the request is going to use. We're grabbing the named instance of user session unit of work. And that's the particular unit of work that we want and that we're going to commit when we're actually doing the insert. So if the user was not null, and I'm sorry, one other step to do here is to actually now set our, oh, no, we've already set it up here, sorry, user. And we're inserting it. And then else, we can say user gets user. And then we need to implement our anonymous method up here as well. And what we can do is we can set a system user. So we're going to end up with a system user here. And I'm sorry, our external ID is required, so we'll pass in an empty string for that guy. All right, now, what do we have left to do? Well, we have to implement our insert on the user session repository. So first thing we need to do is add our ability, you know, we added our, our actual interface method, right? So here, what do we have going on here? It does not contain insert async. Did I not put the word async? I did. Oh, okay, it just took a second. So now that's happy. Now we just have to implement the actual concrete version of that. All right. So our inserts are going to match the same approach that we're using for an insert here, right? But we don't necessarily, we can actually just copy all of this. We just don't need the domain events piece of it. The other stuff is applicable. Yeah, all right. All right, so we now got our insert, which is nothing more than calling on our document session, which is provided to us again through Martin, to go ahead and store that user and then go ahead and mark it as completed. So hopefully this makes some sense. Again, the user session is something that we want to load at the beginning of the request. And if at the beginning of that request, we are receiving from the JWT an external ID of a user that we don't know about yet, we need to insert that user so we have knowledge of them in our database. And we're going to be doing that with a unit of work, which is going to be a particular named instance. So we're going to have 2 units of work that get created at the beginning of each request. One which is going to have a specific name or instance name applied to it. This guy here, user -session -unit of work. And then the other one is going to be the unit of work that is used by the rest of the request to fulfill. All right, so we've got all of the pieces we need in our infrastructure layer here. And so what we're going to end up doing in the next set of videos is, now that we've implemented the base library for our infrastructure layers, we're going to go off and we're going to implement the infrastructure layer for our catalog service. So that's what's coming up next.
Time for a shameless plug for my personal LLC, Keystone Code. I've been doing software development for 20 plus years now, and I've been lucky enough that I played a lot of the different roles that go into software development, from back-end developer, front-end developer, full-stack developer, team lead, head of engineering, chief technology officer, business analyst, and architect. So if your agency or company has any needs across those different areas, whether it be a need from just understanding what those roles are, or have a need to fill one of those roles, either from a training perspective, a mentor perspective, or an actual hands-on perspective, feel free to reach out. So I can be reached at my email address, dmichael@keystonecode.com, or on the website at keystonecode.com. Thanks.